Today we're going to look at solving quadratic equations by two processes, the graphing process and the factoring process. Let's begin by first taking a look at what it means to solve quadratics. So to solve a quadratic equation means the same as find the roots of a quadratic equation or function. And that means that on the graph we are identifying where the parabola or the quadratic crosses the x-axis. That is the same as looking for the x-intercepts on the graph. If we were to identify the solutions or the roots for this graph, we would identify them as 3, 0 and -1, 0. Notice that for these two roots or solutions, we are getting two different x values, -1 and 3, but notice the y values are 0. And that is because on the x-axis, we know that the y value is 0, always. So every time we're finding solutions and roots to a quadratic function, we're basically identifying x values on the x-axis where the graph crosses. The y value will always be 0. Also notice that the graph crosses two places, and that is because we will always have two solutions or two roots for quadratics. So quickly here in summary, two very important concepts. At the roots or the solutions, the y value is always 0, and there will always be two roots for the solutions for a parabola or a quadratic. A quick way to remember that we'll always have two roots is if you look at a quadratic equation, you'll always have an x squared as the highest x power, and that power of 2 there is designating that we're always going to be searching for two x values that will work for that particular equation. So one thing to note is when we're working with our quadratic equations, whether it's the standard form or the vertex form, when we take the y value and replace it with 0, that is an indicator that we are finding roots or finding solutions, because in reality these graphs here will cross at many y values, but when you're being very specific, or when a problem is being very specific in designating the y as a 0 value, they are looking particularly for the exact two x values where this happens, getting 0 for y or getting 0 for y here in the vertex form. Here is a detailed look at the possible solutions that can occur in our graphs. We know we will always have two roots, and that's pretty obvious when the parabola will cross at two different points here on the graph, like we had in the beginning example. But it is possible that the parabola will only touch the x-axis at one point, and that's when the vertex is right on the x-axis. It's possible that the parabola opens up away from the x-axis or downward, in that there are no intersections at all. So no intercepts. But still, in theory, there are two roots or two solutions. And here's an explanation of the nature of the solutions. When you have two intercepts, which is this diagram right here, you're going to have two real solutions that are different. You'll have two different x values. For the one intercept, you're still going to have two roots, and they will be real since they're touching the x-axis, but the two roots will be equal. The two x values will be the same number. So let's say here, I'll call that 1. So the root here we would say is 1, 0, 1, 0. We would identify the root twice. That's also called a double root. If you have no intercept, which is this graph right here, there are still two roots, but they are imaginary. Two imaginary different roots. And on a graph, we will not be able to read what those actual roots are. We will only be able to say that they are imaginary. Okay, so solving by graphing, if you already know how to graph, the majority of the work is done for you. The overall process will be this. Graph the parabola, whichever method you wish, and then identify where the parabola crosses the x-axis. Always give your answers in ordered pairs. Here is an example that I'll do for you. We're given the equation x squared plus 2x minus 3 equals 0. Notice the y here is 0, which designates find the roots or the x values that make y 0. In other words, where does the parabola cross the x-axis? So we begin by finding the vertex xv and yv. So with my calculations, I'm coming up with an xv value of -1, and I've plugged that in for x, and I've got a yv of -4, and I begin to set up my table. I've selected 4 other values for x around -1, and I've got these new y values, and then I graph. So here's a picture of my parabola. It's a pretty skinny parabola, because my graph is pretty small there, but it still follows your vertex at -1, -4, and even if I wanted to do the step method, it checks out. And then I identify, oh, there's where it's crossing the x-axis, and I'm not done my problem until I report that the roots are 1, 0 and -3, 0. So that was solving by graphing. Now we're going to take a look at solving by factoring, which is a more algebraic method. And so before we dive right into the process itself, there's a few things I want you to take note on. If we had x times y equals 0, which is a total situation outside of the parabola stuff, we know that for this to happen, x can be 0, because then you'd have 0 times y, or y can be 0, so that you would have x times 0 to equal 0. So x might be 0, y might be 0. A new situation, but maybe a little bit more complex, if you had an expression that had x times x minus 2 to equal 0, you really have to think a little bit harder here. How can that happen? If this x is 0, or I should say both x's are 0, then you would have this situation here, 0 times -2 equals 0, and that works. So if x equals 0, that's possible. There's another x value that would work, and that's if this x is 2. So if we replace x with 2, we would have this new expression, where 2 minus 2 is 0, times this x value of 2, and we would still have 0 when we multiply. So another x value that works is 2. So we're going to have to use this type of thinking as we set up our factoring process in a minute. Here I have two binomials, each with an x, and we're asking what x values can I put here that would multiply to this to make that 0, and the vice versa. What x do I put here that would make this 0, so that when I multiply to this, I get 0. So one way to actually attack that, and I think you can visualize that if this is -5, you would have 0 times -5 minus 7. That really doesn't matter what that comes out to be, because you're going to multiply by 0 anyway to equal 0. So if x equals -5, this works. And same thing with this one. If x equals 7, you'll have 7 minus 7 is 0, and that multiplies to the other parentheses to make 0. And we've got to use that concept as we do our process in a minute. So please take a couple minutes to record The overall process solving quadratics by factoring. There are 4 steps. Step 1 is going to be making sure that your equation is in standard form and y value is 0. You want everything all on one side of the equation. Then you're going to apply your factoring methods that we talked about last unit or 2 units ago. Check for GCFs, reverse the FOIL. You're going to have an image that's going to look something like that. Step 3 is set each factor to equal 0, which breaks up the problem into 2 smaller equations. And the goal is to find which x makes this group 0, which x makes this factor 0. Solve for each x, write your answer in ordered pairs. Here's the first factoring example we'll do together, which is just like the graphing problem. We know what the roots should be already. But through the factoring method, it's going to look a little different. For step 1, we already have the equation ready to roll. It's already in standard form. Everything on one side of the equation, 0 here for y. In step 2, we begin our factoring methods. There are no GCFs, but I can certainly reverse the FOIL here because it's a trinomial. And so x squared gets factored into x and x. And then I need 2 factors to make a -3 that add to 2. That would be +3 and -1. In step 3, we're going to set up each of these here. X plus 3 equals 0. That will help us find that x value, and then x minus 1 equals 0. That'll help us find that x value. So in step 4, you're solving. We're going to subtract 3 here to get an x value of -3, which we could have figured out just by looking at that right there. Plus 1, x equals +1, and then we know that we'll have -3, 0 for one root, 1, 0 for the second root. And those we know are where the parabola crosses the x-axis. Our second and last example for the notes today, we have to bring over the middle term here. So 7k squared plus 9k equals 0. That's step 1. Step 2 is the factoring step, which I noticed that with 7 and 9, I don't really have a common value other than 1, but I do have k as a GCF, so k can be factored out, leaving a 7k plus 9 equals 0. Notice the problem, we're still equaling 0 here because we're just taking this and writing it in a different way. We're writing it in 2 factors. Then we set up each of these for step 3 to solve. Set up this factor, set up that factor. So this k equals 0, which immediately solves for it at the same time. 7k plus 9 equals 0. Set up that factor. And so subtract 9 to both sides. We have 7k equals -9. Divide by 7. K equals -9/7. And now to write these as ordered pairs, we have 0, 0 as a root. -9/7, 0. And that is the factoring method.